So, good day everyone. My name is Sir Manjay Wilmore Jr. and today we're discussing about related rates. So, from related rates from differential calculus. So, problem 1. A spherical balloon is being inflated. The radius increases at 2 cm per second. How fast the volume is increasing when the radius is 5 cm? So, first, we're gonna take the formula of the sphere because balloon is a sphere. So, V is equal to 4 over 3 pi r cubed. Next, we're gonna differentiate it with respect to t. T means time. So, differentiate it by d over dt. So, dv over dt is equal to 4 over 3 pi. So, r cube. So, we're gonna use the power rule. So, 3 r. So, 3 minus 1 is equal to 2. Next, we're gonna put the dr over dt because it is implicit. Next, we have the radius increases at 2 cm per second. So, this is dr over dt is equal to 2 cm per second. Next, how fast the volume is increasing when the radius is 5%. So, our radius is equal to 5 cm. Now, we're gonna input the dr over dt, then the radius. So, dv over dt is equal to 4 over 3 pi 3. So, bracket 3. Our r is 5 squared bracket, close bracket. Then our dr and dr over dt is 2. Next, our dv over dt is equal to 200 pi. So, 200 pi. Then, our units is centimeter. Centimeter cube per second. So, that is the final answer to problem 1. Our second problem is the melting snowball. So, a snowball melts, so its radius decreases at 1 cm per minute. Find the rate at which the volume decreases when the radius is 3 cm. So, we're gonna take the formula of the volume of the sphere. So, volume is equal to 4 over 3 pi r cubed. Then we're gonna differentiate. So, d over dt. So, dt means this is the time with respect to time. So, dv over dt is equal to 4 over 3 pi 3. So, we're gonna use the power rule. So, bring down the 3 r. Then, 3 minus 1 is equal to 2. Then, dr over dt. Next, our radius is decreases at 1 cm per minute. So, our dr over dt is equal to negative 1. So, negative 1 because it is decreases at 1 cm per minute. Then, our radius. So, find the rate at which the volume decreases when the radius is 3 cm. So, our radius is 3 cm. Now, the, now we're gonna input this in our volume. So, dV over dt is equal to 4 over 3 pi bracket 3 times 5, oh no, sorry, times 3 squared close bracket, then our dr over dt is equal to negative 1. So, dv over dt is equal to, so we're gonna put this in our calculator. So 4. So our dv over dt is negative 36 pi. Then, since we're gonna get the volumes, this means that this is, our unit is centimeter cube per minute. So that is the answer to this problem. Third problem is about sliding ladder against the wall. So a 10-foot ladder leaned against the wall, the bottom slides away at 1 foot per second. Find how fast the top slides down when the bottom is 6 feet from the wall. So first we're gonna let the distance, so b to x, then we let the height is equal to y. So this is x then y. Now we're gonna use the Pythagorean theorem. So we're gonna use this. So Pythagorean theorem. So x squared plus y squared is equal to, so since our hypotenuse is 10 feet, so this is 100. So 10 squared is equal to 100, so 100. Then we're gonna use we're gonna differentiate 8. So d over dx, so with respect to x, then 2 x dx over dx plus y, to y, dy over dx, then what, 0. Now we're going to get the y using Pythagorean theorem. So 6 squared plus y squared is equal to 100. Then divided by 6 squared, so cancel. Then y squared is equal to 100, 6 squared, and square root y is equal to, so we're gonna put it in our calculator. So 100 over 6 squared, sorry, this is sorry, my mistake. So we're going back to Pythagorean theorem. So 6 squared. Then we're gonna put 6 squared to this side. So y squared is equal to 100 minus 6 squared. Then square root y is equal to square root of 100 minus 6 squared is equal to 8. So Ry is 8. So I'm gonna erase this. Y is equal to 8. Now we're going back here. So we're gonna input our x 6, then our hypotenuse is 10 feet. Now we're gonna input this in our Pythagorean theorem. So 2, 6 are dx. So dx over dx is in this 1. Then plus 2, then y 8. Sorry, dy over dx is equal to 0. Then 2 times 6 is 12 times 1, 12, plus 2 times 8 is equal to 16. So dy over dx. Then we're gonna put 12 here, so this is going to be negative. So 16 dy over dx. 16 dy over dx is equal to negative 12. So divide by 16. So cancel. Our dy over dx is equal to negative 12 over 16. 16 or negative 12 over 16 is equal to 0.75. So now our unit is feet per second. So that's it. That is the answer to problem number 3. So our next problem number 4 is about draining water tank in a form of conical tank. So water drains from a conical tank at 10 centimeter cube per minute. The radius is always half the height. Find how fast height increases when height is equal to 4 centimeters. So first, we're gonna get the volume of the conical tank. So the volume of the conical tank is V is equal to 1 over 3 pi r squared times height. Then, since our radius is always half the height, so we're gonna substitute the r. So V is equal to 1 over 3 pi r. So r, R is equal to h over 2 squared times height. Then we're gonna simplify. So 1 over 3 pi. So h squared times height. So h cubed over. So h squared, h to the power of 2 is 4. Then the 3, since the 3 is the denominator, then 4 is always also the denominator, so we're gonna multiply it. So 3 times 4 is equal to 12. Then h cubed pi. So that is the volume. Then V is equal to h cubed pi over 12. Then we're gonna differentiate it. So d over d.
May you have
Our next problem is about draining water tank in a form of conical tank. So water drains from a conical tank at 10 centimeter cube per minute. The radius is always half the height. Find how fast the height decreases when the height is 4 centimeters. Now we're gonna use the formula of the conical. So V is equal to 1 over 3 pi r squared times height. Then our radius is half the height, so V is equal to 1 over 3 pi, then h over 2 to the power of 2, then height. Next is 1 over 3 pi, then h squared, so h squared times height is equal to h cubed over, then 2 to the power of 2, so 4. Next, we're gonna multiply the 3 and the 4. So because 3 and 4 is the denominator. So over 12 pi times h cubed. Next, we're gonna differentiate with respect to t. So d over dt. So dv over dt is equal to, so h cubed, so 3, we're gonna bring down the 3, then divide by 12 is equal to 4 pi h squared. So squared because 3 minus 1 is 2. Next, since we have the conical tank, and since we have the 10 centimeter cube per minute, so that is draining. That means d over dt over dv over dt is equal to negative 10. Then we have the height 4. Then we're gonna input this here. So dv over dt is equal to pi over 4. Sorry. This is negative 10. Then our h is 4 squared. Now, sorry, forgot the d over dh over dt. Now, we're gonna divide it by 4 pi over 4 times 4 dh over dt. Pi over 4 times 4 squared. So, also same here. Pi over 4 squared. So, cancel. So, our dh over dt is equal to negative 10 over pi over 4 times 4 squared. So, we're gonna input it in our calculator. So, negative 10 over pi over 4 times 4 squared. So, our dh over dt is equal to negative 0.80. So, this is centimeter per minute. So that is the answer to this problem. So our next problem is a car moving away from a station. So a car moves east at 30 km per hour and is 40 km from the station. Another car moves north at 5 km per hour and is 30 km away. Find the rate of the distance change. So we're gonna let x is equal to 40 km. Then y is equal to 30 km. Then we're gonna draw it. So this is station, then east, then another car from north. So this is 40 km. Then this is 30 km. Now we're gonna let the hypotenuse to z. So z is unknown. So we're gonna get the z by using Pythagorean theorem. So Pythagorean theorem is x squared plus y squared is equal to the hypotenuse is z squared. Now 40 squared plus 30 squared is equal to z squared. So square root and square root. So rz is equal to square root of 40 squared plus 30 squared. So rz is 50. This is 50 kilometer. So 50 kilometer. Now we have the rate of change of x and y. So our rate of x. So we're gonna erase this drawing so we can have larger space. So our dx over dt is equal to 30 kilometer per hour. Then our dy over dt is equal to 50 kilometer per hour. Then we're gonna use Pythagorean theorem. So x squared plus y squared is equal to z squared. Then differentiate with respect to t. So this is 2x dx over dt plus 2y dy over dt is equal to 2z dz over dt. Since we have x, y, and z, then the rate of change of x and y, so we're gonna input it here. So 2, our x 40, then our dx over dt 30 plus 2, our y 30, our dy over dt is 50 over is equal to 2, then our z is 50 dz over dt. Next, we're gonna divide it by 2 over 50. Also same here, 2 over 50. So we're gonna erase this one so we can have a larger space. So dz over dt, so this cancel. Next, 2 times 40 times 30 plus 2 30 times 50 over 2 over 50. So we're gonna put it in our calculator. So 2 over 40 times 30 plus 2 times 30 times 50 over 2 over 50. So our dz over dt is equal to 54 kilometer per hour. So that is the final answer to this problem. Now our next problem is about circle. Now the radius of a circle at 3 centimeter per second. Find how fast the area increases when the radius is 10 centimeter. So now we're gonna take the formula of the circle. area of the circle. So our area of the circle is pi r squared. Then we're gonna differentiate uh, with respect to t. So time. So dA over dt is equal to pi. So this is power rule. So 2r, then r, dr over dt. Next, since we have the change of rate of the radius of 3, so dr over dt is equal to 3. Then our radius is 10 centimeter. So dA over dt is equal to pi 2 times our radius is 10. Then our dr over dt is 3. Next, we're gonna input it in our calculator. So pi times 2 times 10 times 3 is equal to 65. So our dA over dt is equal to 65. Then our unit is centimeter squared over second. So that is the problem. That is the answer to this problem. Now our next problem is about the cube. So age of the cube increases at 2 centimeter per second. Find rate of volume increases when the age is 5 centimeter. So first we're gonna get the volume. So the volume of the cube is s cube. Then we're gonna differentiate with respect to t. So dv over dt is equal to 3s squared, then ds over dt. Then since we have the age of cube increases at 2 centimeter, so our ds over dt is equal to 2. Then our S means the side, so next is our side or the edge is 5. Then we're gonna input this here in our volume. So dv over dt is equal to 3 times, then s is 5 squared, then our ds over dt is 2. Then we're gonna put it in our calculator. So 3 times 5 squared times 2 is equal to 150. So our dv is equal dv over dt is equal to 150. Then centimeter cube per second. So that is the answer to problem 7. So our next problem is about rectangle. So rectangle has a width of 4 centimeter increasing at 2 centimeter per second, and length is equal to 10 centimeter decreasing at 3 centimeter. Find the rate of the area changes. So the area of the rectangle is length times width. Then we're gonna differentiate with respect to P. So dA over dt is equal to dL over dt. Then our width, so dW over dt. Then since we have the one where we have the dW over dt, so this is 2, then dL over dt is equal to, since it is decreasing, so negative 3. So dA over dt is equal to our dL, negative 3, then negative 6. Okay. About rectangle. So rectangle has width is equal to 4 centimeter increasing at 2 centimeter per second, and length is equal to 10 centimeter decreasing at 3 centimeter per second. Find area changes. So the rate of find rate area changes. So our area of the rectangle is length times width. Then differentiate with respect to t. So dA over dt. Then this is product rule. So W times dL over dt plus length times dW over dt. Then we have length is equal to 4. Then dL over dt. Sorry, our length is equal to 10. Then our dL over dt is equal to 2. 3. What? So this is negative. Then our width is equal to 4. Then dW over dt is equal to 2. So it is increasing, so positive 2. Then we're gonna put it here. So our W is 4 times our dL. Our dL over dt is negative 3 plus our length 10 times 2. Then our dA over dt is equal to, so we're gonna put it in our calculator. So 4 times negative 3 plus 10 times 2. So 8. Then centimeter squared per second. So that is the answer to problem 8. So problem number 9, object moves along x-axis. X is equal to 3t squared. Find rate of distance from origin when t is equal to 2. So x is equal to 3t squared. So differentiate it with respect to t. So dx over dt is equal to 6t. Then rt is equal to 2. So dx over dt is equal to 12. Since 6 times 2 is 12. Then x is equal to 3t squared is equal to, then put our t in x, so x is equal to 2 times t 2 to the power of 2. So 2 to the power of 2, 4 times 3 is 12. So x is 12. Since z is equal to absolute value of x, so dz over dt is equal to dx over dt. So our dz over dt is equal to 12 unit per second. Our next problem is about cylindrical tank. So a cylindrical tank is filled with water at rate of 100 cubic meter per second. Radius is 5 centimeter. Find how fast the height increases. So our volume of the cylindrical tank is V is equal to pi r squared times height. Then since we have the this is cube. So since our radius is 5, so we're gonna input the 5 in r. So v pi r cube 5 mali ba? Pwede ba 25 man? Next problem is about cylindrical tank. So a cylindrical tank is filled with water at rate of 100 cubic meter per second. Radius is 5 centimeter. Find how fast the height increases. So our volume of the cylindrical tank is V is equal to pi r squared times height. Then since we have radius is equal to 5, so we're gonna input the 5 in our radius. So V is equal to pi 5 squared times height. Then pi 25 h. Next, we're gonna differentiate it with respect to t. So dv over dt is equal to 25 pi times dh over dt. Since we have since we have the dV over dt of 100 cubic meter per second, so 100 is equal to 25 pi dH over dt. Then divide by 25 pi. So R cancel. dH over dt is equal to 100 over 25 pi. So we're gonna input that in our calculator. So 100 is over 25 pi is equal to dH over dt is equal to 1.27 27 meter per second. Now we're on problem 11. So this problem is about spotlight. So a spotlight from 20 meter from a wall rotates lighting a spot on a wall. If the angle changes at if the angle changes at 0.2 rad per second, how fast is a spotlight moving when the angle is pi over 4? So in our illustration here, so a spotlight 20 meter from a wall, so this is our 20 meter. Then we have x, then we put the angle here. So we're gonna use tan is equal to opposite over adjacent. So tan theta is equal to opposite over adjacent. Then we're gonna multiply both sides by 20. Then we're gonna differentiate it with respect to t. So here, so this is the differentiation of 20 tan theta is equal to dx. Then we're gonna find the angle. So secant squared theta is equal to, so since we have the given pi over 4, so secant squared pi over 4 is equal to, so since this is, so we're gonna put it in our calculator. Then since this is pi, we're gonna convert it into angles. So convert it, so 1 over cos squared is equal to pi over 4 times 180 over pi. So the answer is 2. Then so 20 times 2. Then since we have given d theta over dt, so 0.2 pi rad per second. So times 0.2 is equal to dx over dt. So when I put it in our calculator, so 20 times 2 times 0.2 is equal to 8. So our dx over dt is equal to 8. So that is the final answer to problem 11. Now, on problem 12, an airplane flies horizontally at 300 kilometers per hour. So this is R, sorry. So at altitude of 4 km. How fast the distance from radar station changing when plane is 3 km horizontally away? So, an airplane flies up horizontally, so flies horizontally at 300 km per hour at altitude, so 4 kilometers. How fast is the distance from radar station changing when 3 km horizontally away? So we let x is equal to 3 and y is equal to 4. Then we're gonna use Pythagorean theorem. So x squared plus y squared is equal to z squared. So we're gonna find z. So square root. So cancel. Square root. Our x is 3, so 3 squared plus y. Our y is 4 squared is equal to z. Then square root of 3 squared plus 4 squared is equal to 5. Is equal to z. So our z is equal to 5. Now we're gonna change, we're gonna find the change of rate of z. So x squared plus y squared is equal to z squared. So we're gonna plug in 4 squared. 4. So x squared plus 4 squared is equal to z. So we differentiate with respect to t. So we take 2 x dx over dt plus 0, then 2 z dz over dt, then 2z, so divided by 2z, so we can cancel this, then remaining by dz and dz over dt. So I'm gonna erase this distribution, so we're gonna have a larger space to answer. Then 2, our x is 3, then our dx over dt is 300, yes, also 300, so 300 over 2z, so this is equal to dz over dt. Then we put it in our calculator. So 2 times 3 times 300 equal to 2. Oh, sorry. Our z is 5. So 5. 2 times 5 is equal to 180. So our dz over dt is equal to 180 kilometer per hour. So that is the answer to this problem. Now, in problem 13, a square side grows at 2 cm per second. Find how fast the diagonal grows when the side is 5 cm. So we're gonna use the formula of diagonal. So diagonal is equal to s squared of 2. Then we're gonna differentiate it. So with respect to time, so d over dt, then d over d over dt is equal to copy square root of 2 since it is constant, then ds over dt. Then we're gonna plug in 2 centimeters squared. It is because it is the ds over dt. Our ds over dt is equal to 2. So it is positive because it grows. So d over d over dt is equal to square root of 2 times 2. So we're gonna plug it in our calculator. So square root of 2 times 2 is equal to 2.83 centimeter per second. That is our d over dt. This is the change of rate of that side. So yeah, of the diagonal. So our next problem is a man pull a rope to a lake 10 feet above the ground. If he walks away at 3 feet per second, how fast is the rope moving through the lake? So in our drawing here, so we let the hypotenuse to L, means the length of the rope, then X, also the 10 feet above the above the ground. So this is 10 feet. So we will let this Y. So X is unknown. Y is 10. Now we're gonna use Pythagorean theorem. So Pythagorean, so L squared is equal to X squared plus Y squared. At X is equal to 6. X is equal to 6. So L squared is equal to L is equal to 6 squared plus 10 squared. Then we put it in our calculator. So square root of 6 squared plus 10 squared is equal to 2 square root of 32. Then, so we have the length 2 square root of 32. I put it in our 2 square root of 32 because we're gonna use the because we're not going to I forgot about it, but I'm gonna use this 32 square root of 32 as a whole, not as a decimal. Then now L squared is equal to X squared plus Y squared. Then multiplied by differentiate as respect to time. So 2L dl over dt is equal to 2 Oh, forgot about it. Sorry. So x, no, L squared is equal to x squared plus y squared. So we're gonna put in y squared, x squared plus y, ry, then so L is equal to x squared plus 100. Then we're gonna differentiate it by with respect to time. So 2L dl over dt is equal to 2x dx over dt. Then this is constant without variable, so this means 0. Now we're gonna plug in this variable, also the dx over dt, which is the 3 feet per second. So this is x because he walks away. Then then 2 RL, then no, 2 times 2 square root of 32 is equal to 2 RX 6. Oh, forgot about it. 6 times 3 forgot the d L over dt. Then divide both sides by 2 times 2 square root of 36. So cancel. I'm gonna erase this one so we can have a large space to write. So RDL over dt is equal to 2 times 6 times 3 over 2 times 2 square root of 36. So the answer is 1.5 feet per second. So that is the answer to problem 14. Now our next problem is changing height of a triangle. In a triangle, base is 12 centimeter and constant. Height increases at 1.5 centimeter per second. Find the rate of the area changes. So now we're gonna use the area of a triangle. So the area of the triangle is 1/2 base times height. So now we're gonna differentiate it. So with respect to time, so dA over dt is equal to 1/2. Since it says that the base is constant, so the base is 12, then height. dh over dt. Now, since we have height increases at 1.5 centimeter per second, so our dh over dt is 1.5. Then it is positive because it increases. So dA over dt is equal to 1/2 divided by 1/2 times 12 is equal to 6 times 1.5. So if you plug in our calculator, so 6 times 1.5, 6 times 1.5. So the answer is our dA over dt is equal to 9 centimeter per second. So that is the answer to this problem. Now, on problem 16, the radius of the sphere grows at 1.1 meter per second. Find how fast the surface of the area increases when the radius is 4 meter. So first, we're gonna use the area of the sphere. So the area of the sphere is equal to 4 pi r squared. Then we're gonna differentiate it. So with respect to time, d over dt. So dA over dt is equal to 4 pi because it is constant. Then 2r dr over dt. Then since we have the radius of the sphere goes at 0.1 meter per second, so r dr over dt is equal to 0.1. Then find how fast the area increases when the radius is 4. So our radius is 4 meter. Now we're gonna plug it in. We're gonna plug those into our differentiate area of the sphere. So dA over dt is equal to 4 pi 2 times 4, 8. Then our dr over dt 0.1. Then our dA over dt is equal to, so if we plug it in our calculator, so 5 times 8 times 0.1. So the answer is 10.05. So the answer is 10.05. So the unit is meter per second. So that is the answer to this problem. Now, the next problem is about sun faults. Sun. So sun faults forming a cone radius is equal to height always if volume increases at 10 centimeter cube per minute. Find the rate height changes when the height is 6 centimeter. So first, we're gonna use the volume of the cone. So the volume of the cone is 1/3 pi r squared times height. So now we're gonna differentiate. No. Since the radius is equal to height, so if we change the radius to height, it will be like this. So V is equal to 1/3 pi r height cube. So that is the changes when the radius is equal to height. Then we're gonna differentiate it. So d over dv, oh no, dt. So dv is equal to dv over dt is equal to 1/3 pi, since it is constant, then 3h squared times dh over dt. Since we have height of 6 centimeters, so our height is 6. Then it is said that the volume increases at 10 centimeter cube per minute. So our volume is equal to 10. So we plug it in here. So this is 10 is equal to 1/3 pi bracket 3 times our height is 6 squared, close bracket. Then we have dh over dt. So dh over dt, oh no, we don't have dh over dt, I'm sorry. So copy dh over dt. Then we can multiply 10 by 1/3 pi times 3 times 6 to the power of 2. So it will be look like this. So 10 over 1 over 3 pi. So 6 times 6, 36 times 3. So 36 times 3 is equal to 108. Then is equal to dh over dt. So if we calculate this, so 10 over 1/3 pi 108, it will be equal to our dh over dt is equal to 0.09 centimeter per minute. So that is the answer to number 17. Problem number 18. A point moves along the parabola. Y is equal to x squared, such as that x is increasing at 2 units per second. Find the rate of y when x is 3. So an equation of y is equal to x squared. Then if we differentiate it with respect to t, this is dy over dt. Then 2x dy over dx over dt. Since we have dx over dt of positive 2 unit per second, then we have the x is equal to 3. We can solve the dy over dx using this 2, then put it in this equation. So dy over dt is equal to 2, then our x 3 times 2, so 2 times 3 times 2 is equal to 12. So our dy over dt is equal to 12 unit per second. Problem number 18. One car heads north at 60 km per hour, another is at 80 km per hour. How fast is the distance between them changing 2 hours after they start from the same point? So after 2 hours, our x is equal to 120. Then Ry is equal to 160 because it is 80 km per hour. After 2R, it will be 160. Then we're gonna solve Z. Then we're gonna solve Z. So we're gonna use Pythagorean theorem because in our drawing, another car head east and another car head north, another car head east. So we're gonna find this one. So this is our x and this is our y. So we're gonna use Pythagorean theorem. So x squared plus y squared is equal to c squared. Then 120 squared plus y, no way, 160 squared squared is 2 in z. So square root of 120 squared plus 160 squared is equal to 200. So RZ is equal to 200. Now we're gonna find the distance between them changing after 2 hours after they start from the same point. So again, we're gonna use also the Pythagorean theorem. So x squared plus y squared is equal to c squared. So differentiate it with respect to time. So 2x dx over dt plus 2y dy over dt is equal to 2z dz over dt. Then divide both sides by 2z. So it will be cancel. So 2x dx over dt. Oh, we're gonna plug in this one. And we're gonna plug in this one. So 2, our x is 120. Then our dx is 60. Plus 2, our y is 160. Then our dy is 80. Over 200 is equal to dz over dt. So if we plug in this one, our answer is, so we're gonna find out. So 2 times 180 times 60 plus 2 times 160 times 80 over 2 times 200. So the answer is 118 dz over dt. Oh, sorry, the unit. Forgot the unit. So our dz over dt is kilometer per hour. So 118 kilometer per hour. So that is the answer to problem 19. Sorry about this one. So we have error this one because this is 60. So if we plug in this, in our calculator, the answer will be dz over dt is equal to 100 kilometer per hour. So, problem number 20. A 31 feet ladder leaned against a wall. The angle between the ladder and the ground is decreasing at the rate of d theta over dt is equal to 0.05 rad per second. Find how fast the top of the ladder is sliding down when the wall is pi over 4. So first we're gonna draw. So this is the wall, this is the ground, and this is the ladder. Since our ladder is 31 feet, then the angle between the ladder and the ground is decreasing at the rate of d theta. So this is the angle. So we'll let the wall to y. So we're gonna use sine. So sine theta is equal to y over 31. Then multiply both sides by 31. So we can have 31 sine theta is equal to y. Then we're gonna differentiate with respect to t. So it is 31 since it is constant. Then cos is equal to dy over dt. Then we're gonna find the value of the cos theta. So cos theta, since our theta is equal to pi over 4, then convert it into a degree form, degree. So 180 over theta. So it is equal to square root of 2 over 2. So we have the value of cos theta. Then our value. Then 31 times square root of 2 over 2 is equal to dy over dt. So we can I forgot the d theta over dt is equal to dy over dt. So we have also here, since it's d theta, so 0. So it is said it is decreasing at the rate of d theta over dt is equal to 0.05. So it is negative 0.05 dy over dt. Now, now we're gonna use our calculator to calculate this one. So 31 times square root of 2 over 2 times negative 0.05. So the answer is may I calculate it? So 31 times square root of 2 over negative 0.7. So the answer is dy over dt is equal to 1.1. So the unit is rad per second. Feet per second. So that is the answer to problem 20. So problem number 1. Ripple spread in a motor, so the radius increases at 0.5 meter per second. How fast is the area of the ripple increasing when the radius is 10 centimeter? So first, we're gonna take the area of the ripples. So A is equal to 4 pi r squared. Then we're gonna differentiate with respect to time, so d over t. So dA over dt is equal to 4 pi times 2r dr over dt. Since we have the increasing radius, so dr over dt is equal to 0.5. Then we have the radius of 10 centimeter. So our dA over dt is equal to 4 pi times 2 times 10 is 20 times, so it is increasing, so it is positive, so 0.5. So if we compute this using our calculator, so 4 pi times 20 times 0.5. So the answer is 40 pi. So our dA over dt is equal to 40 pi. Then on our units is meters squared per second. So that is the answer to number 21 problem. Number 21. So problem 22. Boat A is at 30 km/h and the boat B is heading north at 40 km/h. At a certain moment, boat A is boat A is 3 km east of a dock and a boat B is 4 km north of the same dock. How fast is the distance between the boats changing at the moment? So first, we're going to illustrate this one. So our boat A is heading east. So this is our east. Then, so 30 km/h. 30 per hour. Then boat B. So this is A, boat A. Then boat B. So boat B is heading north at 40 km/h. At the moment, boat A is 3 km. Then, km east of the dock. Then, boat B is 4 km. Or north of the same dock. How fast is the distance between the boats changing at the moment? So we're gonna use, so this is what distance between two points. So we're gonna use Pythagorean theorem. So we're gonna let this x, then this is y. So x squared plus y squared is equal to c squared. And square root, cancel 2. So rz, square root, rx is 3 squared plus y 4 squared is equal to z. So if we plug in that in our calculator, the answer will be 3 squared plus 4 squared 5. So RZ is 5. So RZ is 5. Next, we're going to find the change of rate of this between point A and point B. So we're gonna use also the Pythagorean theorem. Y squared plus x squared is equal to z squared. Then derive as respect to time. So 2y dy over dt plus 2x dy over dt is equal to 2z dy over dt. Then we're gonna multiply both sides by 2. So to cancel out 2. So 2, 2, 2. So y is equal to dy over dt plus x this is x dy over dt is equal to z dz over dt. Then we're going to plug in the values here. So ry is 3 times r dx is 30 plus it's 14, sorry, plus plus 3 times 30 is equal to 5 dz over dt. Then multiply both sides by 5. So when I erase this, we don't have much space. So yeah. So 4 times 40 plus 3 times 30 is equal to dz over dt is over 5. So if we put it in our calculator, dz over dt is equal to 50. So Then our units is kilometer per hour. So 50 kilometer per hour. So that is the answer to this problem. So the next problem is problem number 3. Water is being poured into an inverted conical tank at rate of 10 centimeters squared per second. The tank has a height of 30 centimeters and a top radius of 10 centimeters. How fast is the water level rising when water is 12 centimeters deep? So we have first we have the conical tank. So dV over dt equal tank at rate of 10. Then the tank has a height of 30. So we have 30. So height of the tank is 30. Then and top radius of 10 centimeter. So radius is 10 centimeter. How fast is the water level rising when the water is 12 centimeter deep? So the height of the water is 12 deep. So first of all, we're gonna use the radius over height. Then 30 are height, so conical tank sa height, conical tank of height of the conical tank. Sorry for so our radius 10 over 30. So 1 over 3 radius over height of a tank. Then we're gonna multiply both sides by h, which is the height of the tank. So r is equal to h over 3. Then we're gonna use the formula of the volume of the conical tank. So B is equal to 1 over 3 pi r squared times height. Then we're gonna plug in the radius into this volume. So to this formula, so 1 over 3 pi height over radius squared to the power of 2, then height. Sorry, this 3. So first we're gonna do the denominator. So 3 squared is equal to 9 times 3 is 27. Then copy pi. Then h to the power of 2 is h squared times h is h cubed. So we have the volume. So I'm gonna erase this one so we can have a larger space. So copy this. V is equal to pi over 27 times h cubed. So I'm gonna erase this now. Next, we're gonna differentiate it with as respect to time. So d over dt. So dv over dt is equal to h cubed. So you're gonna bring down the 3, then divide by 27 is 9. So it's 9 pi h squared. So that is the differentiate of this formula. Next, we're gonna plug in the height of the water. So dv over dt is equal to pi over 9, then times 12 oh I forgot, sorry. So this is dh over dt. So we're also going to plug in the dv over dt. So this is 10. So pi over 9 times 12 squared dh over dt. Now we're gonna multiply both sides by pi over 9 times 12 squared. Also this one. So pi over 9 times 12 squared. So cancel. So our dh over dt is equal to, so we're gonna plug in this in our calculator. So 10 over pi over 9 times 12 squared. So the answer is 0.199. What's that? So our sorry. So our unit is centimeter over per second. So that is the answer to this problem. So problem number 24. Water is being poured into a conical tank at a rate of 3 centimeter cube per second, cubic centimeter per second. The tank is 30 centimeter tall and has a radius of 10 centimeter at the top. How fast is the water level rising when the water is 15 centimeter deep? So first is the given value. So conical tank, so dv over dt is equal to 3. Then the tank is 30 centimeter tall, so the height of the tank is 30 centimeter. Then it has a radius of 10 centimeter. At the top, how fast is the water rising when the water is 15 centimeter deep? So the height of the water is 15. Now R over H is equal to 10 over 13. Then r over h is equal to 1 over 3. Multiply both sides by h. So r is equal to h over 3. Then, we're gonna use the volume of the conical tank. So V is equal to 1 over 3 pi r squared times height. So V is equal to 1 over 3 pi r squared. No. We're gonna substitute the r to the radius into this formula. So h over r, this is 3 squared times height is equal to 3 squared, 3 to the power of 2 is equal to 9 times 3 is 27. Then copy pi, then h to the power of 2 is h squared times 3 times h is h cubed. So V is equal to pi over 27 times h cubed. Now I'm gonna erase this one, then copy this one here. So V is equal to pi over 27 times height to the power of 3. So I'm gonna erase this. Then differentiate both sides with respect to time. So dv over dt is equal to pi over 27 because it is pi over 27 is a constant. Then times, so bracket, 3 h cube squared. Then dh over dt. Then dv over dt. So 3 over 27 is 1 over 9. So h squared dh over dt. Then, since we have height of the water and dv over dt, so we can plug in that here. So dv over dt is 3, so equal 1 over 9. Oh, I forgot pi. The pi. Put this pi. Then RH is 15. Then squared, then dh over dt. Then multiply both sides by pi over 9 times 15 squared, then pi over 9 times 15 squared. Then cancel. So we're gonna input this in our calculator. So 3 over pi over 9 times 15 squared. So the answer is our dh over dt is equal to 0.38. So the unit of this is centimeter per second. So that is the answer of number 24. So problem number 25. Car A is traveling east toward on a intersection at 60 km per hour, and a car B is traveling north towards the same intersection at 80 km per hour. At a certain moment, car A is 3 km from intersection. While car B is 4 km from intersection, how fast is the distance between two cars changing at the moment? So, in our drawing here, so car A is toward east. So east. So this is east. So an intersection at 60 km per hour. Then, and car B is traveling north toward the same intersection at 80 km per hour. So this is 80 km per hour. Then, at a certain moment, car A is 3 km from intersection. So this is 3 km. Then, while B is 4 km. From the intersection. How fast is the distance between two cars changing at the moment? So we're gonna find this. So change of rate of the hypotenuse, or the distance between two cars. So let 60 km, or this side into x, then this side to y. So and this side is z. So first, we're gonna use the Pythagorean theorem. So the Pythagorean theorem is x squared plus y squared is equal to z squared. And square root. So rz is equal to square root of rx. So 3 squared plus 4 squared. So rz is equal to 5. So we have z is equal to 5. Then we're gonna also use the Pythagorean theorem to find the changing point of or the rate between two cars. So we're gonna use also the Pythagorean theorem. So x squared plus y squared is equal to z squared. Differentiate. So this is going to be 2x d over dx. Oh, sorry, too small. So 2x dx over dt plus 2y dy over dt is equal to 2z dz over dt. Since they have both sides 2, so we're gonna cancel it, or we're gonna divide it by 2. So I'm gonna choose to cancel it since it's this whole. So cancel 2 and 2. So we have x. Sorry, I'm gonna. Where's the eraser? Ah, sorry. So we have x dx over dt plus 2y, no, this is y dy over dt is equal to z dz over dt. Then we're gonna subtract each of the value here. So our x is 3, then our dx is 60 km per hour, so 60 plus our y is 4, then times 80 km per hour is equal to 5 rz. Then copy dz over dt. Then multiply both sides by 5. So erase this one. So consider this one 5. So our dz is over dt is equal to, so we're gonna put it in our calculator. So 3 times 60 plus 4 times 80 over 5. So our answer is 100. Then our units is kilometer per hour. So that is the answer to this problem. So problem number 26. Find the dimension of a rectangle with a perimeter of 26 that has the maximum area. So first we're gonna let length is equal to x, then width is equal to y. Then we're gonna use the perimeter of our rectangle. So the perimeter of the rectangle is p is equal to 2 times x plus y. Then it is given that the perimeter of the rectangle is 20. So this is 20 is equal to 2x plus 2y. Then divide both sides by 2. So our x is equal to, this is 10 is equal to x plus y, then minus x, then minus x. So y is equal to 10 minus x. Then we're gonna use the area of a rectangle. So the area of the rectangle is x times y, or length times width. Then we're going to substitute y to our area. So a is equal to x times 10 minus x. Then copy a, or the area, then x times 10 is 10x, then x times negative x is negative x squared. Then we're going to differentiate with respect to x, d over dx. Next, dA over dx is equal to 10 minus, so power rule, so negative 2x. Then we're gonna let dA over dx into 0. Then 10 minus 2x. So I'm gonna erase this one. So positive 2x and positive 2x. So cancel. So 2x is equal to 10. Then divide two sides, the two sides into 2. So cancel 2. X is equal to 5. Then our length, or y, is also 5. So that is the dimension of the rectangle. So the unit of the dimension is centimeter. So problem number 27. A square piece of cardboard 10 inches on a side is used to make a box by cutting squares from each corner and folding up sides. What side should be cut to maximize the volume? So in the drawing, so we have 10 inches cardboard box, then cut the edges by X. So now our base is equal to 10 minus 2x. 2x means because there are 2x in both edges of the 10 inches cardboard box. Then our volume, so x times 10 minus 2x squared. Then we're going to expand 10x minus 2x. So b is equal to x times 100 minus 40x plus 12. No. So, sorry. This is 20x plus 4x squared. Oh, sorry. This is 40. Then, we're gonna multiply x to this side. So, 100 x minus 40x squared plus 4x cubed. So I'm gonna erase this one side. So we're gonna differentiate this. So prime b is equal to 100 minus 80x plus 16x squared. Then we're gonna let prime b to 0. So 100 minus 80x plus 16x squared. Now we're gonna use quadratic formula. So, I'm sorry, so there is a mistake. So this is 12. Now, we're gonna use quadratic formula. So, in our calculator, we're going to mode 5, then quadratic equation. Then, input 12, positive 12, then negative 80, then 100. So Rx is equal to Rx is equal to 0.67. Then the unit is inches. So that is the answer to this problem. So, a farmer wants to fence 100 meters of land along a river. Only fencing 3 sides. What dimension give the max area? So, let length is equal to x, then let width is equal to y. So first, our perimeter is 100, then is equal to x minus 2y, then minus x, so minus x, so cancel. Oh, sorry, this is plus. Then 100 minus x is equal to 2y, then divide by both sides by 2, so 50 minus x over 2 is equal to y. Then we're gonna use the area, so the area is equal to x times y. Then we're gonna plug in this y to this area, so x times 50 minus x minus 2. Then multiply x to 50, then multiply x to negative x over 2. So this is 50x minus x squared. We can just do 1/2 x squared. Then we're gonna differentiate. So dA over dx is equal to 50 minus, so we're gonna use power rule. So this 2, now we're gonna bring down this 2, then divide by 2 is equal to 1, so will be x. Then so I'm gonna erase this one. Then let dA over dx equal to 0. So 0 is equal to 50 minus x. Then so positive x and positive x. So Rx is equal to 50. Then Ry is equal to 25. Then to find the area, so we're gonna use this one. So our area is equal to 50 times 25. So to plug that, to find the area, so we're gonna use the calculator. So area is equal to 1,250 square inches, square meter. So that is the area of a land. So problem number 29. Find the point in the line y is equal to 2x plus 1 closer to the point 3 and 0. So we're gonna use distance formula. So d is equal to square root of x minus 1. So x minus 3 squared. So we got this from here. So since x is equal to 3, then negative 3 and negative 3. So x minus 3 is equal to 0. So that is how we get this one. Then plus 2x plus 1 power of 2. Then to minimize, so we're gonna b squared, then x minus 3 Then we're gonna derive it. So by deriving, so this is 2d oh, sorry, not yet. So first we're gonna expand this one. So this is x squared minus 6x plus 9 plus 4x squared plus 4x, then plus 1. So 2x squared plus 4x squared is 5x squared. Then negative 6x minus 4x is equal to negative 2x. Then 9 plus 1 is positive 10. Then we're gonna derive it. So by deriving, we get d, oh sorry, 2d over x is equal to 10x minus 2. Then we're gonna let d go 0. So 0 times 2d is equal to 0. Then x is 2. Then Rx, so 0 is equal to 10x minus 2. So positive 2. So 2 is equal to 10x, then divided by 10. So Rx is equal to 1 over 5. Then, to find the y, we're gonna use this one. So y is equal to 2. Rx is 1 over 5. Then, plus 1. So 2x to the power 5 plus 1. Then y is equal to 7 over 5. So our answer is 1 over 5, then 7 over 5. So that is the answer to this problem. So problem number 13. So find the radius of the cylinder with volume 1000 cubic meter that minimizes surface area. So first, we're gonna use the volume of the cylinder. So pi r squared times height. Then, since the volume is 1000, so 1000 is equal to pi r squared times height. Then, divide by both sides by pi r squared. So pi r squared. Then, our height, so our height is 1000 over pi r squared. Then, we're going to use the surface area. So, the surface area is 2 pi r squared plus 2 pi rh. So, first, we're gonna substitute h this. So, s is equal to 2 pi r squared plus is not squared. So r times 1000 over pi r squared. So, sorry, it is squared. So, squared. Next, so, cancel pi. Then, so, our copy is pi r squared plus 2 pi, no, 2000 over r. Then, so the denominator is, the least common denominator is r. Then 2 pi r cubed plus 1000. Oh no. Oh, sorry. It's not. So we're gonna differentiate it. So s is equal to 2 4 pi r plus negative 2000 over r squared. Next, so this is prime s. So I'm gonna erase this one. So this common denominator is r squared. So 4 pi r cubed minus 2000. Then we're gonna let s to prime s to 0. So 0 is equal to 4 pi r cubed minus 2000. Then over r squared. Then multiply both sides by 2r. So cancel. So 0 times 2r is also 0. So 4 pi r cubed minus 2000. So I'm gonna erase this part. So plus 2000. So plus 2000 the other side. So cancel. So 4 pi r cubed is equal to 2000. Then divide by both sides by 4 pi. So it will be r cubed. So it's equal to 2000. No, 5000. So because 2000 divided by 4 is 500 divided by over pi in square root, cube root. So cancel. So RR is cube root of 5000 over pi. So we get the radius. Second, we're going to find the height. So if you remember, our height is equal to 1000 over pi r squared. Then we're gonna plug in here. So 1000 over pi are 2/3. So it can be rewritten into 2/3. So RH. So we're gonna use our calculator. So 1000 over by very sorry. 5,000 over pi power of 2/3. So 5,000 over pi to the power of 2/3. So the answer is 10.84. Then our units is centimeter. So that is the answer to number 30. So problem number 31. So find both two non-negative numbers that sum to 10 and have the largest product. So let the numbers to x and 10 minus x, because it's non-negative. Two non-negative. Then product is equal to x times 10 minus x. Then multiply, so 10x minus x squared. Then prime p is equal to 10 minus 2x. So we're gonna let prime p into 0. So 10 minus 2x. Then positive 2x, then plus positive 2x. So Rx 2x is equal to 10 divided by 2 divided by 2. Rx is equal to 10. Then so Rx is 10. Then 10 minus 5 is equal to 5. So both non-negative is 5. So the answer is 5. So another problem number 32. Find two numbers that sum to 20 and minimize the sum to their squares. So net numbers is equal to x and 20 minus x. So then s is equal to x times s equal to x squared plus x 20 minus x to the power of 2. Then we're gonna expand this one. So s is equal to x squared plus, so 20 squared is equal to 400. So 400, sorry. 200 minus 40 x plus x squared. So 2x squared plus minus 4dx plus 200. So then we're differentiate. So differentiate with respect to x. So s s prime is equal to 4x minus 40. Then, we let x into 0, so 4x is equal to 4x minus 40. Then, plus 40. Then, plus 40. So, I'm gonna erase this part. So, you can have then 40 is equal to 4x. Divided by 4, our x is equal to 10. Then, if we substitute x to 20 minus x, it will be equal to 10. So, 10 is the answer. Now, next problem. So, problem number 30. Find the length of the shortest ladder that clears 4 feet tall and 3 feet from a wall. So, the ladder. So, this is the triangle. So, the ladder, the length. Then, a fence tall. So, this is 4. Then 3 feet from a wall, so 3. So this is our theta. So we're gonna use sine theta is equal to, so opposite over hypotenuse, so 4 over 3. Then cosine theta, which is 3. Oh, sorry. This is L. 4 over L. Then 3 over L. Now, the length is equal to sine theta sorry. So, we're gonna multiply both sides by L. So, L, so switch. So, L is equal to 4 over sine theta. Also, this one, so L is equal to 3 over cos theta. Now, our length is equal to sine 4 over sine theta plus 3 over cos theta. Then, we're gonna differentiate it. So, I'm gonna erase each of this. This one, 2. So, L. So, differentiate. So, L prime is equal to sine squared x, squared theta plus the denominator. So, the denominator is sine, so negative 4 times cos theta. Then, plus, so, cos squared x squared theta. Then, this is positive 3 sine theta. Now, we're gonna let L prime to 0. So, there is this one, so I'm gonna put it in 0. So, now, multiply both sides by sine squared theta times cos squared theta. Then it will be 0 is equal to negative 4 cos cube theta plus 3 sine cube theta. Now, we're gonna put in this one. So, sine theta over cos theta is equal to square root, cube root of 4 over 3 so tan, so sine over cos is equal to tan theta is equal to cube square root of 4 over 3. Then theta is equal to arctan of cube root 4 over 3. So if we put it in our calculator, so arctan cube root of 4 over 3 is equal to theta is equal to 47.74 29 60. So I'm gonna erase this one. So if you remember, length is equal to 4 over sine theta over sine theta plus 3 cos theta. So this theta, when you plug it in here, also here. So so 4 over sine our answer, so plus 3 over cos. So our length is equal to 9.87. So the the unit is feet. So that is the answer to this problem. So problem number 34, find max area of a rectangle inscribed under y equal to 4 minus x squared. So let point the curve be x and 4 minus x squared. So our area of a rectangle, so area is equal to 2x times 4 minus x squared. Then multiply, so it will be 8x minus x cubed. Then we're gonna differentiate with respect to x, so a prime is equal to 8 minus, so it will be 2, so minus 6x squared. Then we're gonna let a prime to 0, so I'm gonna erase this, so it will be changed to 0. So then this negative 6x to the power of 2, I'm gonna move it to the other side, so it will be 6x squared is equal to 8. Then divide by 6, then square root of square root, so cancel. So x is equal to square root of 4 over 3. Now we have the x. Now, I'm going to solve for the area. So, again, the area is 2x times 4 minus x squared. Then, 2 times square root of 4 over 3 times 4 minus 4 over 3 squared. So, I'm gonna bracket this one. So, the answer will be so the answer is 6.16 unit squared. That is the answer. So, problem number 35. Find the rectangle of the largest area that can be inscribed under the line y is equal to 6 minus x. So, that line is equal to x and 6 minus x. So, area is equal to x times 6 minus x. Then multiply, so 6x minus x squared. Then we differentiate the area, so 6 minus 2x. Then we let the area, the prime a to 0. So I'm gonna erase this and put it 0. So this negative 2x, I'm gonna move this to other side, so it will be 2x is equal to 6, then divided by both sides by 2, x is equal to 3. Then I'm gonna find the area. So the area is equal to 3 times 6 minus 3. So 6 minus 3 is 3 times 3 is 9. So our area is 9 unit squared. So problem 36. So find the area rectangle of the area 36 centimeters squared with the smallest perimeter. So first, we have a given 36 area of 36 centimeter. Then in our drawing, this is x and this is 1. So the total area of this rectangle is 36. So x and y is equal to 36. Oh, sorry. X and y is equal to 36. Then we divide both sides by x, so we can have the y. So 36 over x. Now we're gonna find the perimeter. So perimeter, this is equal to 2x plus 2y. Then we plug in the y. So p is equal to 2x plus 2. Our y is 36 over x. Now, then simplify. So 2x plus 2 times 36 is 72 over x. Now, we're gonna differentiate it. So we're gonna times both sides by d over dx. So prime 1, prime p is equal to, so this is going to be 2 plus so the plus negative 72 over x squared. So this is quotient rule. Then we're going to find the least common denominator. So prime 1 is equal to, our least common denominator is x squared. So x squared times 2, so 2x squared plus, oh no, this is going to be negative, so because this is negative 72, so negative 72. Then, so I'm gonna erase this part. So now we'll let p is equal to 0. Oh no, this p prime p. So 0 is equal to 2x squared minus 72 over x squared. Then multiply both sides by x squared. So we're going to be x is equal to 2x squared minus 72. Then we're going to move negative 72, so it can be positive negative 2. So to the other side. So 72 divided is equal to 2x squared. Now we're going to divide both sides by 2. Then square root. To cancel squared. So cancel. Then if you plug in square root of 72 over 2, it's going to be 6. So our x is equal to 6. Now we're going to find the y. So I'm gonna erase this one. If you remember, our y is equal to 72. This is going to 72. This is 36 over x. Next, we plug in our x into this. So our y is equal to 36. Now, we're going to find the perimeter since we have the x then the y. So perimeter is equal to 2x plus y. So it's equal to 2, 6 plus 6. Then RP is equal to 24. Then don't forget the units. So the units is centimeter. So that is the answer to our problem 36. So problem number 37. Find the dimension of a closed cylinder with a volume of 500 cubic centimeter that minimizes the surface area. So first, we're gonna use the volume of the cylinder. So the volume of the cylinder is pi r squared times height. Then, since the volume is 500 cubic meter, so 500 is equal to pi r squared times height. Then divide by both sides by pi r squared. So h is equal to 500 over pi r squared. Now we're gonna get the surface area. So surface area is equal to 2 pi r squared plus 2 pi r h. Then we're gonna plug in the h. So 2 pi r squared plus 2 pi times 500 over pi r squared. Then 2 pi r squared. So we're gonna simplify this. So cancel pi. So 2 times 500, so 1000. So we're gonna forget the r. So we're gonna put, so 1000 r. Then we're going to differentiate. So s prime. Then we're going to be 4 pi r plus. So this is going to be plus. So it will be negative 1000 over r squared. So this is quotient rule. Next, so I'm gonna erase this. Next, so we're going to get this s into 0. 0 is equal to, then common denominator. So the common denominator is r squared. So 4 r squared times 4 pi r, it will be 4 pi r cubed minus 1000. Then, so I'm gonna erase this one so it won't be confusing. It would be confusing. So next is multiply both sides by r squared. So it will be 0 is equal to 4 pi r cubed minus 1000. Next, the 1000, we will move it the other side, so it will be positive. So 1000 is equal to 4 pi r cubed. Then divide by both sides by 4 pi. Then cube root, because r is cubed. Cancel. So r is cube root of 250 over 5. Next, we're going to plug this to our height. So the height is equal to 500 over pi r squared. Then h is equal to 500 over pi cube root of 250 over pi. So RH is equal to, so if we put it in our calculator, the answer will be 8.60. Then the units, so units is centimeter. So that is the answer to problem number 37. Problem number 38. Find the point on the line y is equal to 2x plus 1 closest to the origin. So d squared is equal to x squared plus 2x plus 1 squared. Then x squared plus 4x squared plus 4x plus 1. Then 5x squared plus 4x plus 1. So d. So we're going to different with respect to x. So 2d prime is equal to 10 x plus 4. Then since now we're going to let d prime equal to 0. So 0 times 2d equal to 0. So equal to 10x plus 4. Then we move 4 to the other side, so it will be negative is equal to 10x, so divided by 10 both sides, so cancel, will be negative 2 over 5, that is our x. Then we're going to find the y. So y, our y is this one. So y is equal to 2x plus 1. Then we plug in our x, 2 times negative 2 over 5 plus 1. So if we put it in our calculator, so 2 times negative 2 over 5 plus 1 will be 1 over 5. So the closest point will be negative 2 over 5 dash and 1 over 5. That is the answer to this problem. So the problem number 39, find the shape of a triangle with a perimeter 30 that gives the surface area. So this means that the triangle is equilateral triangle. So first we're going to use the perimeter. So since it is equilateral triangle, so it will be 3a. Then since we have given 30 perimeter, so 30 is equal to 3a divided by 3 both sides. So our a is equal to 10. Then since a is the sides of the triangle, so we're gonna use Heron's formula. So a is equal to square root of, then to use Heron's formula, we're going to find the semi-perimeter. So the semi-perimeter is equal to 30 over 2. So our semi-perimeter is 15. So 15 times 15 minus our sides, so 10. Then since it is it is same side, so we're going to just put to the power of 3 here. So to find the area, we're going to compute this one. So 15 square root of 15 times 15 minus 10 to the power of 3. So our answer is 43.30 unit squared. So it is unit squared because it is not, the unit is not given, so we're going to use unit squared. So that's it. So problem number 40, find the dimension of an open half cylinder of volume 100 cubic centimeter with the minimum surface area. So first, we're going to use the volume of the cylinder. So V is equal to pi r squared times height. That is the volume of a cylinder. Then, since we have given 100 cubic centimeter, so our volume is 100 then pi r squared times height. Then, divide by both sides by pi r squared. So RH is equal to 100 over pi r squared. Then, we're going to use the surface area of a cylinder. So, pi r squared plus 2 pi r h. So, then, we're going to put RH to this one. So, pi r squared, so copy this one, plus 2 pi r squared times 100 over pi r squared. Oh, sorry. This. Then, cancel. Then, pi r squared plus 2 times 100 is 200 over r. Then, we're going to differentiate this one. So, S prime is equal to 2 pi r plus, now this is going to be negative, so negative 200 over r. Then, we go erase this one. So, we're going to find the least common denominator. So, S prime is equal to 2 pi r this is going to be squared. Sorry. 2 pi r cube minus 200 over r squared. Then we're going to put we're going to let S prime to 0. Then multiply both sides by r squared. So it will be 0 is equal to 2 pi r cube minus 200. Then negative 200 we're going to put in another side, so it will be positive. Minus is equal to 2 pi r cube. Then divide by both sides by 2 pi. Then square cube root. So r is equal to cube root of 100 over pi. So I'm gonna erase this one. So if you remember, RH is equal to 100 over pi r squared. Then we let the r to this one, so to height equal to equation to height, so h is equal to 100 over pi square root of 100 over pi over 2. So 100 over pi times cube root. Sorry, this is cube root. Cube root of 100 over 5 squared. So RH is equal to 3.17 centimeter. Then R is cube root of 100 over 5 centimeter. So that is the answer to this problem. That's all. So problem number 41. So maximize area of a rectangle under y is equal to 9 minus x squared symmetric about x-axis. Now we're gonna let, so A, or the area, is equal to 2x is equal to 2x times 9 minus x squared. Then we're going to multiply this one, so it will be 18x minus 2x cubed. Then we're going to differentiate this one, so d over dx. So prime a, so we're going to get prime a, then 18 minus 6x squared. Then we're going to let a is equal to 0, or I mean a prime. Then 18 minus 6x squared. Then we're going to move this negative 6x squared to other side, so it will be 6x squared minus equal to 18. So divide 6, then square root, then cancel. It will be remain x, and this will be 3. So 3 square root of 3 from here. So square root of 18 over 6, so square root of 3. Then we're going to find y. So y is equal to 9 minus square root of 3 to the power of 2. Then cancel square root, cancel 2 to the power of 2. Then it will be 9 minus 3, and y is equal to 6. So the answer is Rx is square root of 3, then Ry is 6. So problem number 42. So 100 meter of fencing one side against a barn maximize area. So a perimeter, this is perimeter, so P is equal to 100. Then RP is equal to x plus 2y, then RP is 100. So we're going to move this x, so it will be 2y is equal to we're going to shortcut, so 100 minus x over 2, so this will be Ry. Then our area is equal to x and y, x times y. Then area is equal to x times 100 minus x over 2. Then x times 100, so 100x, then minus x squared over 2 is a. So now we're going to differentiate this. So a is equal to 4 is 100. Now 4 times 100 minus 2x. Then minus 100 will be 100 x minus x squared times 0. So this will be cancelled. So the remaining is 4 and times 100 minus 2x over 4. Yeah, it will be over 4. Oh no, this is 2. I'm very sorry. So there is 2. So I'm gonna erase this one. So a prime. Then we're gonna let this a prime to 0. So 0. 2 over 4 is will be 1/2. So 110 minus 2x over 2. Then since we can divide this both sides, so it will be 50 minus x. Then our x will be 50. Then then we're going to find how we're going to get the y. So since y, I'm gonna erase this one. Since our y is equal to 100 over x. So so there is something wrong with this one. So 100 square meter is 100. Very sorry, I'm gonna call this one. So x plus 2y. Ah, okay. Minus x over 2. Then y is equal to 100 minus 50 divided by 2. So it will be y is 25. So we're going to we're going to solve the area. So area is x times y. So 50 times 25 equal will be 50 times 25. It will be, our area is 1250 meter squared. So that is the area number 34. So problem 43, maximize area of a triangle with a perimeter of 75. So first, perimeter is equal to, so this triangle is an equilateral triangle, so maximize. So it will be 3 sides. Then since our perimeter is 75, it will be divided by 3. So 75 divided by 3 is 25. So that is our S. So the side. So now we're going to use Heron's formula. But first we're going to get the semi perimeter. So we have a perimeter of 75, so it will be divided by 2. So 75 divided by 2 is 37.5. So our semi perimeter, oh sorry, we're going to get this side into at least x. Sorry, so we will be confusing about semi perimeter. So x, so s is equal to 37.5. Then we're going to now use the Heron's formula. So square root of semi perimeter, so 37.5 times 37.5 minus Rx is 25. But since we have the same side, so we just put the power of 3 here. So the area is equal, should be square root of 37.5 times 37.5 minus 25 to the power of 3. So our area is 270.63 centimeter cube square. So that is the area of, that is the answer to problem 43. So problem 44. So you have 80 meters of fencing to build a rectangular garden. One side of the rectangle borders a river and does not require fencing. What are the dimensions that maximize the area of the garden? So let x is equal to length and y is equal to width. Then since we have 80 meters and this is perimeter, so 80 is equal to x plus 2y. Then we're gonna let x is equal to 80 minus 2y. Then we're going to use the area. So the area is equal to x times y. Then we're gonna input this one, rx, so 80 minus 2y, it will be 80y minus 2y squared. Then we're going to differentiate this one. So a prime is equal to 80 minus 4y. Then we let this into 0. So 80 is minus 4y. Then we're gonna, this negative 4y, or put it in the other side, it will be 4y is equal to 80. So divided by both sides by 4, our y is equal to 20. Then since we have the y, it will be meters. Then rx, we're gonna find the x. So x is equal to 80 minus 2y. Our y is 20. Then with 40, rx is equal to 40. So the answer is the x is equal to 40 meters and y is equal to 20 meters. So that is the answer to number 44. So problem number 45. You want to make a cylindrical can that holds 1 liter 1 liter or 100 centimeter cube of liquid. Find the radius and the height of the can that minimize the surface of the area or the amount of material used. So first, we're going to use the volume of cylindrical. So the volume is pi r squared times height. Then since we have we have volume, so 1000, so pi r squared h. Then we're going to get the h. So in order to do that, h is 1000 over pi r squared. So that is our h. Next, we're going to get the surface area. The surface area is equal to pi 2 pi r squared plus 2 pi r h. Now, now we're going to substitute this h to this area as surface area. So a is equal to 2 pi r squared plus 2 pi r 1000 over pi r squared. So a is equal to 2 pi r squared plus, so it will be 1000 over r. Then we're going to differentiate this one. So a prime is equal to 2 pi, no, this will be 4 pi r plus, oh no, sorry, this will be negative 2000 over r squared. Then very sorry, I'm gonna erase some of this one, so maybe this. Now we're gonna let a to 0, so 0 is equal to, so first we're going to find this common denominator, so r squared, then 4 pi r cubed, then minus 2000, then multiply both sides by r squared, it will be 0 is equal to 4 pi r squared cubed minus 2000. Then this 2000 will move to other side, will be 2000 is equal to 4 pi r cubed over 4 pi. This will be cube root. So IR is equal to cube root of 500 over pi. Now we're going to get the height. So I'm gonna erase this one. So height is equal to 1000 over pi r squared. Then 1000 over pi times cube root of 500 over pi. So the answer will be, H is equal to 58.74 centimeter. And RH is cube root of 500 over pi centimeter. So that is the answer to number 45. So problem 46. So you want to build a rectangular enclosure with an area of 200 square meter. What dimension will be minimize the perimeter? So first, our our area is 200 square meters. So area, so 200 is equal to this area, so x and y. Then we're going to get the y. So y is equal to 200 over x. Then the we're going to use the perimeter. So perimeter is equal to 2x plus 2y. Then we're going to plug in this one. So 2x plus 200 over x times 2. Then 2x plus 400 over x. Then we're going to differentiate this one. So p prime is equal to 2 plus negative 400 over x squared. Then we're going to find this common denominator. But first, let p is equal to 0. So 2x squared minus 400 over x squared. Then multiply both sides by 2x, so it will be 0 is equal to 2x squared minus 400. Then our 400 will be moved to other side, so 400 is equal to 2x squared, then divided by 2 square root. So our our x is equal to square root of 200. Then we'll go erase this one. So we cannot this way. So or x is equal to 14.14. Then y is equal to 200 over 14.14. So to plug in that one in our calculator, so 200 over 14.14, it will be the same. It is 14.14 meter. So this is also a meter. So the answer is this one, because the findings the dimension. So that's it. Now problem number this will be 48. So problem number 48, you are to rectangle under the curve of y is equal to 9 minus x squared, where the top side of the rectangle touch the parabola and the base lies along x-axis. Find the dimension of the rectangle with the largest area. So first, our area is equal to, so width is equal to 2x and height is y is equal to 9 minus 2x. So 2x times 9 minus x squared. Then multiply, so it will be 18x minus 2x cubed. Then differentiate, this will be 18 and this will be 6x squared. Then we let a to 0, so 18 minus 6 squared. Then negative 6x squared will be put in the other side, so 6 is equal to 18, 6x squared will be equal to 18, so divided by 6 squared, so 3 square root of 3. Our x is square root of 3. Then we're going to find the y. So y y is equal to 9 minus square root of 3 to the power of 2. So cancel the square root, then ry is equal to 6. So that is the answer to our problem 48. So the unit is, oh sorry, we don't have unit, so it will be units. Okay, that's one. So problem number 49. You are build a box with a square base and no top must have a volume of 500 cubic meter. Find the dimension, base, and length and height that minimize the surface area and choose material cost. So first, sorry. So first, our volume of the box is volume of the box is x squared times height. Then since we have 500 volume times x squared times height, then divided by x, so we have that h is equal to 500 over x squared. Then the surface area is x squared plus 4 x times height. So that is the surface area of the box. Then a is equal to x squared plus 4x times 500 over x squared. Then a is equal to x squared plus 2000 over x. And a prime is equal to 2x plus, no sorry, a negative 2000 over x squared. Then we let a prime into 0. 0 is equal to 2x. So common denominator, this will be x cubed minus 2000 over x squared. So multiply both sides by x squared, so it will 0 is equal to 2x cubed minus 2000. Then 2000 we will move to other side, so 2x cubed is equal to 2000 to, then divided by 2 cube root, then cube root, so our x is equal to 10. Now we're going to get the height. So our height is equal to 500 over 10 squared. So our h will be our h will be 5. Then we're going to solve the surface area. Though a is equal to, our x is 10 squared plus 4 times 10 times 5. So our surface area will be equal to 300 cubic centimeter. So that is the answer to problem 49. So problem 50. You want to design a cylindrical can that holds exactly 2000 cubic meter of liquid. Find the radius and height of the can that minimize the surface area. So first we have 2000 cubic meter of cylindrical can. So the volume is equal to pi r squared times height. Then, since we have 2000, so it's equal to pi r squared sine. So we're going to get the height. So height is equal to 2000 over pi r squared. Then we're going to get the surface area. So the surface area is equal to pi r squared. So these two plus pi r squared times height. Oh, these two. Then we're gonna plug this one to here. So 2 pi r squared plus 2 pi r squared times 2000 over pi r squared. Then copy 2 pi r squared plus will be 4000 over over r. Then derive it. So a prime, so 2, no, this will be 4 pi r plus no negative 4000 over r squared. Then we're going to let a to 0. Then a 4 pi r cubed minus 4000 over r squared. So I'm gonna erase this one. So 0. So multiply both sides. So 0 is equal to 4 pi r cubed minus 4000. Then divided by, so this 4000 will be go to other side, so will be 4000 is equal to 4 pi r cubed. So divided by 4 pi, then cube root. The answer will be, so our calculator, cube root of 4000 over 4 pi. So the answer will be R is equal to 6.83 meter. Then we're going to get the height. So 2000 over pi, r is 6.83 squared. So 2000 over pi times 10 squared. So our h is equal to 13.66. Then we're going to get the surface area. So surface area is A is equal to 2 pi r. R is 6.83. So squared, then plus 2 pi r 6.83 times height 13.66. So in calculation, so 2 pi times 6.83 squared plus 2 pi 6.83 times 13.66. So equal our area, surface area is equal to 879.31 meters squared. So that is the answer. Also this one. So that is the answer to number 45. So that's it. So that's all the 50 problems of 50 problems of total of related rates and maximum minima. Thank you.